This is a reassessment video for rotational dynamics, and our scenario says that a child pushes a merry-go-round from rest to a final angular speed of 0.50 revolutions per second with constant angular acceleration. In doing so, the child pushes the merry-go-round 2.0 revolutions. A, what is the time it takes for the child to push the merry-go-round in 2 revolutions? And B, what is the angular acceleration of the merry-go-round? So first we need to identify what we're given. And it says the merry-go-round started, initially it was at rest. So our initial angular speed is 0 radians per second. Because that needs to be our angular speed, needs to be in radians per second here. And then our final angular speed it gave us was 0.50 revolutions per second. And to get this in units that we want to work with, which is radians, we're going to say multiply it by 2 pi. And so it comes out to pi radian per second for the final angular speed. And then also we're given the displacement, how far it went. Said the child pushes it 2 revolutions. And again, revolutions we need to get in a form that we want to use, radians, so we'll multiply it by 2 pi. And we get 4 radians as the displacement. A, let's look for the change in time. And we're going to use the formula that the average angular speed is equal to the change in displacement over the change in time. And since we're looking for the change in time and we have both of these, we're going to set up our equation in this way and fill in our values. We know that our displacement is 4. We found out it's 4 radians. That goes on the numerator. And then the average angular speed is equal to 1/2 times the initial angular speed plus the final. And so right here we use this as our average angular speed, and we solve algebraically and find out that the change in time for it to go 2.0 revolutions is 8 pi seconds. And time wants to be in seconds, so we know that our units are correct. And then B says, what is the angular acceleration of the merry-go-round? If you can see that. And so here we're going to use this formula that says, right here, our change in displacement equals the initial angular velocity times time plus 1/2 the angular acceleration times time squared. So we know all our values except for the angular acceleration, so we're going to plug in everything, solve for that, and we're going to come out to it's about 0.39 radians per second squared. And again, our acceleration, we know we need it to be in distance per second per time squared, so we know that we have our units correct there as well.